Really important to understanding the greenhouse effect is knowing how the properties of energy from the sun are different than the energy emitted from the earth. Higher temperatures of the sun mean that the energy emitted has shorter wavelengths and is more intense. Energy from the cooler earth has longer wavelengths and is less intense. Let's take a closer look at this. This image shows the electromagnetic spectrum. Energy travels from the sun in streams of photons, or electromagnetic energy. Photons are characterized by a wavelength and radiation intensity. Wavelength dictates how the waves behave. Energy from the sun is mainly in the ultraviolet and visible wavelengths, while energy from Earth is mainly in the infrared wavelengths. Radiation is transmitted by the atmosphere, from the sun, shown in red, and from the earth, shown in blue. The Earth's atmosphere is made up of various gases, including nitrogen, carbon dioxide, methane, water vapor, and others. The different properties of each of these gases means that they can absorb energy in different parts of the electromagnetic spectrum. That means that the energy received by the surface of the Earth is less than what is received at the top of the atmosphere, because some of the energy is absorbed by the atmosphere. However, most gases in the atmosphere are not particularly good at absorbing shortwave energy, so about 70 to 75% of the energy from the sun reaches the Earth's surface. This is shown in red in the first panel. The blue graph shows that the energy emitted from the Earth is more highly absorbed. About 15 to 30% passes through the atmosphere. This is because gases in the atmosphere are much better at absorbing long-wave energy. The region of the electromagnetic spectrum where light can pass through is referred to as the atmospheric window. Click to see the plot showing energy absorbed by the atmosphere. Notice that this graph is the mirror image of the red and blue parts of the energy transmitted by the atmosphere. Energy not transmitted through the atmosphere has to be absorbed by it. Click to see the wavelengths absorbed by different gases. The gases are ordered by their relative importance. Let's make sure everyone understands these graphs by asking a few simple questions. Is ultraviolet energy from the sun transmitted through the atmosphere or absorbed by the atmosphere? Ultraviolet light is absorbed. Which gas is absorbing most of the ultraviolet light? Ozone. Why is this important? Ultraviolet light damages living organism cells. If ozone wasn't absorbing energy in these wavelengths, life as we know it would not exist. Is carbon dioxide absorbing short or long-wave radiation? Long-wave radiation from the Earth. The energy absorbed by the atmosphere is re-radiated in all directions. Some of it is re-radiated back to Earth, increasing the total amount of radiation received by the Earth.